last time with that parameter 1, C, I'm sorry, not 1. So one parameter, C. In this case, we do have A, B. So we have two parameters. Okay, now I have to dig up my stuff from, I just put in the encyclopedia. Okay, so now this is the other half. So my question is, first of all, for you, when we just looked at this, how many parameters we had in this function? How many parameters?
1.
Yes. How many equations did we need?
3.
If I have one parameter?
1.
1. Good. Maybe I should leave it here and not put in the recycling just yet. Who knows, I may need it. Okay, what do you think we need if we have two parameters? How many equations?
We'll need 2 equations.
Of course. If we have two variables, we need two equations. If we have two parameters, the same thing. 2 equations are required. Good. So first of all, I'm going to start.
I'm sorry, is that a plus 6 at the bottom?
This one?
Yeah.
It's the parameter B.
Oh, okay. Thank you.
Sorry about that, my handwriting. Okay. So we have a parameter A and a parameter B. That's why we have 2, so we need 2 equations. So I cannot stress enough, simplify, factor. Okay? I'm hoping that everyone will move on from this class remembering to simplify all the time and to factor if it's possible and if it simplifies the function. Always, always. Okay, so there is nothing I can do here. There is nothing I can do here. But can I simplify that one?
Yes.
Yes. How?
X2 minus 4 becomes x minus 2 plus x plus 2.
Good.
I mean, times x plus 2.
I meant to write minus, of course. And x minus 2. Good. So then what will I do?
Cancel out the x minus 2 and the x minus 2.
Very good. But remember, I have to make sure before I cancel or simplify that x is not 2. Otherwise, I have to state a restriction. And only then I have to do this. But is x equals 2 here?
No.
No. So there is no need. Valid? No need. Because it's not 2 is not there anyway. So this whole thing already changed into simple x plus 2. Just from the get-go. The rest I have to copy. There is nothing I can do. So ax squared minus bx plus 3 for this. And for x minus a plus b for this. Good. So they're asking us in this problem, find a and b that make f of x continuous everywhere. By everywhere, we mean this, of course. Negative infinity to infinity. Okay, so far so good. I will quickly write that this and this and this, number 1, x plus 2, ax squared minus bx plus 3, as well as 4x minus a plus b, are continuous functions as functions. What are they? What category of functions do they come from?
Polynomial.
Thank you very much. Awesome. Brilliant, thank you. As polynomial functions. Now in step number 2, I have to discuss what happens at 2. So continuity at x equals 2. For this function to be continuous at 2, what has to happen? And that is the very important definition from last time. This is crucial. This is the definition of continuity at the point. Now, what do I write here and what do I write here?
For the first one, we write x plus 2.
And this one. Excellent. Good. I agree. So the first one would be x plus 2. And the other one would be ax squared minus bx plus 3. Good. So now, can anyone give us the number here? I can do this because I apply the limit. To be super exact and nice, I should write it from the beginning. But we have it here. What do I get? Excellent. Thank you, Sean. Now here, what do I get here?
4a
Excellent.
minus 4b.
You mean 2? Yes. 2b, yes.
2b.
And plus 3. Excellent. And now, where do I get f of 2 from? Do I use this or do I use this? 1 or 2?
We use 2.
Very good. So I still have 4a minus 2b plus 3, which is the same thing with this. So I will say the same. So now I'm going to call this equation A. Can anyone give us the equation A that makes this function continuous at 2? What do I have to write to make this function continuous at 2?
Set 4 equal to 4a minus 2b
Absolutely.
plus 3?
Exactly. They have to be the same. So I found my first equation, 4a minus 2b plus 3 must equal 4. Of course, I'm going to move 3 to the other side, and I have 4a minus 2b equals 1. This is my first equation. Excellent, but not good enough. I have 2 parameters. I need 2 equations. But I only analyzed continuity at 2. So now I have continuity at 3 to analyze. And that's the last step, right? Step 3, continuity at x equals 3. So again, the same thing. As x approaches 3 from the left must equal the limit as x approaches 3 from the right must equal f of 3. Please remember these definition. This definition and how it is applied in these 2 cases, please. Okay, back to limit as x approaches 3 from the left. Which one do I use?
Second one.
Of course, makes no sense otherwise. Ax squared minus bx plus 3. Okay, and of course, from the right, I have to use 4x minus a plus b. And now let's see what we get. What is this equal to? I don't need to write the limit because I am determining it. How much is this?
Nine a minus 3b plus 3.
Perfect, excellent. Thank you, Ash. So now we're here.
Minus a plus b.
Excellent. And of course, this will be the same. How do I know? Because of the equal symbol. I have to use the same thing. It will still be 12 minus a plus b. Good. So now this is my equation b. Can anyone tell us what will equation b consist of? What is it? Anyone?
It would be 9a minus 3b plus 3 equals 12 minus a plus b.
We have to, thank you so much. We have to clean it up. So I'll bring an a here. So I have 10a. I will have to bring a b here. It was positive, now it's negative. And I will have to move 3 to the other side. It was positive, now it's negative. So this is our equation b. Now I have to combine a with b into a system of two linear equations with two variables, or in two variables. Let me see where I'm with that. Oh, I'm fine. Okay, so a with b together. 4a minus 2b equals 1, and 10a minus 4b equals 9.
So I have a question.
Yes?
If we're adding b to minus 3b, would that not make it minus 2b?
So this was negative.
Mm-hmm.
When I move it to the other side, it becomes positive. 9 plus 1 is 10. This was positive.
I see what you're saying.
When I move it to the other, that's okay. I'd rather check. Maybe you see something I don't. It's okay. It's fine. So b was positive. When I move it to the other side, it becomes negative. I have a negative 3b minus b is negative 4. I'd rather check. And then when I move 3 to the other side, it becomes negative. 12 minus 3 is 9. Are we okay?
Yeah, we're good.
Excellent. Good. So I don't know what you want to do, but I would like to eliminate b, multiplying the first equation by negative 2. So negative 8a plus 4b equals negative 2, and 10a minus 4b equals 9. b is gone. 10 minus 8 is 2a. 9 minus 2 is 7, so a equals 7 halves. With a equals 7 halves, I will go back to the first equation. So 4 times 7 halves minus 2b equals 1. Of course, I'll simplify. So 14 minus 2b equals 1, or negative 2b. I move 14 to the other side, it becomes negative. 1 minus 14, negative 13. So b equals 13 halves. So my ordered pair is a comma b, a 7 halves, b 13 halves. Not good enough. I'd like to move on, but not good enough. Must check in both equations to make sure that there is no mistake. So 7 times 4, that is indeed 14. Minus 13 is 1. I'm going to check anyway. So 7 halves is 35 minus 26. Wait. So I have 10 times 7 halves minus 4 times 13 halves. I have to check this now. So this is 35 and this is 26. Yes, it is 9. So good. Check. Only now I can say yes. For sure. I checked in both. Both work. This must be the solution. Not good enough. I have to go back and put them back in. If I have something like this on a test, I have to go back and replace A by 7 halves, both places, and B by 13 halves, both places, and rewrite the function. So let's do just that, and that's the end of it. Any questions before we do that?
I have one.
Yes?
So since they're two different functions, how are you able to just add them together? Is there like a deeper reasoning to that, or is it just what we do?
What do you mean two different functions? We're talking about f of x. We are talking about f of x. What do you mean by two different functions?
So farther down when we set them and we add them together.
I'm not
So
adding,
since they're
I'm not
eventually-
adding anything together. I'm not adding anything together. I'm only saying this. I'm only saying that the point when x equals 2, for the function to be continuous, the limit from the left, the limit from the right, and the function value have to be the same. And I made them the same, determining the appropriate and the exact a and b. Not this a, the parameter a and the parameter b. I didn't add anything. Oh, you mean in the system? Adding
Yeah,
the
sorry, I should've
oh. Okay. Good point. So the question is it clear that I'm allowed to multiply both sides by -2 without changing anything?
Yeah.
Perfect.
Okay.
Perfect. And now imagine this, that we have one side equals, I keep losing my props. Okay, so we have these two. Forget about the numbers or what it's in there. I'm telling you this equals this. I'm also telling you that this equals this. If these two quantities are equal to each other, can I add them here? So I'm telling you that this is 5 and this is 5. Can I add 5 to both sides of this?
Yeah, because they're both the side of a function.
Yes, that's why.
Okay, gotcha.
Oh,
Thank you.
sorry, I misunderstood. I should have clarified that first.